Okay, we're going to continue on with exponent laws in lesson 4 for chapter 3, powers and exponents. And we're going to look at the last 3 exponent laws today. We're going to look at power of a power, power of a product, and power of a quotient. These examples are all going to involve brackets. And so let's start. Okay, so again, we're going to continue using repeated multiplication. In this case, I hope you notice that we only have one base. In the other product rules, we had 2 bases yesterday. This product rule, we only have 1 base. And so in this case, we have 2 to the power of 3, and then we have another exponent outside of the brackets. So we're going to start on the outside and work our way in. So 2 to the power of 3 is our base, and so that is what is going to be repeated 2 times. So 2 to the power of 3 times 2 to the power of 3. I can either leave it in the brackets or I can take it out of the brackets because it's a positive base. Then I'm going to look and I'm going to see, okay, well, I've got 2 to the power of 3. So this is telling me to go 2 times 2 times 2 times 2 times 2 times 2. Not sure where that 3 was coming from. And so all together we have 1, 2, 3, 4, 5, 6, or 2 to the power of 6. Okay, looking at B. Again, looking for our base. Our base is inside the brackets. So 7 to the power of 2 is going to be repeated 3 times. So 7 to the power of 2 times 7 to the power of 2 times 7 to the power of 2. I can use brackets or not because it's a positive base. Then we've got 7 to the power of 2 times 7 to the power of 2 times 7 to the power of 2. So again, our base is 7 and it's being repeated 6 times. So in this case, they both happen to have the same base just because I wanted to pick small exponents to work with. But hopefully you noticed that 2 times 3 or 3 times 2 gives us 6. And so when we have an exponent with another exponent, so a single base and then exponent with another exponent, the exponents are multiplied. So this is the same as A, our base, with the exponent times the other exponent. The base stays the same, the exponents are multiplied. So that's our third exponent rule. This is the power of a power rule. So we have a couple examples. 8 to the power of 3 to the power of 5. So again, we have a base of 8 to the power of 3, and it's being raised to another exponent. And so we can use our power of a power rule. So this is the same as 8 to the power of 3 times 5. So just the exponents get multiplied. And that's the same as 8 to the power of 15. The second one, we have a base of 3 to the power of 8 to the power of 4. So we can take our base, multiply the exponents, 3 to the power of 32. That's it. It's that easy. These examples are going to show us our next exponent rule. And this next exponent rule I'm showing you right now with numbers. Normally it's going to apply when we have different variables or different expressions inside a bracket with an exponent outside the bracket. I'm going to show you it with numbers right now just to make it seem a little bit easier. But I hope you notice that if we were going to follow BEDMAS, we would multiply these 2 values together first. Right? We would go 2 times 3 and then get negative 6 to the power of 4. I want to show you the exponent rule, so we're going to ignore that just for a second to investigate this exponent rule. And so what the exponent rule says is that when you have an exponent outside of brackets where there's multiplication going on inside the brackets, the exponent applies to everything inside the bracket. So this is like saying 2 is going to be multiplied 4 times, and -3 is going to be multiplied 4 times. Okay? And when we evaluate this, if I put -6 to the power of 4, so negative base with an even number exponent, we will get a positive answer, and we get 1,296. 1,200. And if we solve these other two pieces, so 2 to the power of 4, we get 16 times -3, so a negative base to an even exponent, we're going to get a positive value. So we get 16 times positive 81, and we also get 1,296. So same value. The way on the left would be the way I would prefer you to solve it. However, the way on the right is demonstrating our exponent rule. So when we look at the second example, again, I would expect you to go 35 to the power of 3, because you're going to solve what's inside your brackets before applying any exponents. But if we're demonstrating the exponent rule, this is like saying 5 3 times 7 3 times. So 5 3 times 7 3 times. And we could leave it at that. We don't need to solve it like we did in A. So this is showing our power of a product rule. Power of a product. So two values being multiplied, so A times B to the power of M. That means the exponent applies to everything inside the brackets. So A is going to get the exponent and B is going to get the exponent. The most common instance where you would see something like this would be like if you had 3 times A times B times Y, and then to the power of 2. Well, the 3 would get the power of 2, the A would get the power of 2, the B would get the power of 2, the Y would get the power of 2. So 3 squared, A squared, B squared, Y squared. This is kind of the most common situation you would see that in, because we couldn't multiply those first, because we don't know what A is, we don't know what B is, we don't know what Y is. So again, these two examples, I would expect you to multiply 5 times 4 first, but if we're demonstrating the product of powers rule, power of 3 applies to the 5, power of 3 applies to the 4. So 5 to the 3 times 4 to the 3, and that's it. On the second one, 3 to the power of 3 times 9 to the power of 3. Okay? And this one you could actually write as a single power. And as a challenge for you, I want you to try and see how could you write this as a single power and prove to me why you can do so. If you can show me that, I'm going to be pretty amazed. I might even give you some bonus. Okay, our last rule that we want to look at for this lesson is the power of a quotient rule. And so that says if you have two things inside your base that are being divided, that the exponent applies to both pieces. And so again, you could technically go 3 divided by 4 and get 0.75 to the power of 3, but we're trying to demonstrate our exponent rule. And so what this says is that the exponent of 3 applies to the numerator, and the exponent of 3 also applies to the denominator. So we have 3 to the power of 3 over 4 to the power of 3. Okay, or if we wanted to go one step further, we could go 27 divided by 64. And if, just for argument's sake, we wanted to double check that these values were the same, so if we go 0.75 to the power of 3, we get, as a decimal, 421.875. And if I go 27 divided by 64, we get the same thing, 0.421875. So these values are the same. But this is how we would represent our power of a quotient, power of a quotient. Looking at the second example, again, we have a quotient or division statement inside of our base. So the 4 is going to apply to both the numerator and denominator. So 2 to the power of 4, 5 to the power of 4. And that's as far as you have to go. And so this is our power of a quotient rule. So this says that when you have a base that involves division, both the numerator and the denominator receive the exponent. The exponent applies to both. And again, this would be an example. You would see things like if you had letters. So maybe 2x divided by 3y all to the power of 4. This is like 2 to the 4, x to the 4 over 3 to the 4, y to the 4. This exponent is applying to everything. Okay, so the last two examples, we're going to apply the exponent to the full base. So the exponent of 5 is going to apply to the numerator as well as to the denominator. So 7 to the 5 over 2 to the 5. Looking at our last example, same thing. Power of 6 is going to apply to the numerator as well as the denominator. So 7 to the 6 over 8 to the 6. And that's it. So those are all of your exponent laws. If you hadn't filled in your cheat sheet on the back of your outline, make sure you take a minute to do so now. And you're going to have a quiz pretty soon. So you're going to want that cheat sheet available to you.